Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, mathematics is magical. We'll see one of the most remarkable magic tricks I know of. It comes from the outstanding book Magical Mathematics, written by two magicians who happen to be excellent mathematicians, and also vice versa. This is actually many tricks in one. I'll show you a couple of versions. The deck needs to be specially prepared differently for each trick. In each trick, you ask a volunteer who can follow instructions and do a riffle shuffle, lay the cards down, have the volunteer cut the deck once, and then deal about half the cards one by one to make a new stack. Then do one riffle shuffle of the two halves. Here's the version that I've gotten the best reaction from. It uses the cards ace through 10 in each suit, 40 cards total. After the riffle shuffle, pull off the top 10 cards and have a volunteer pick any two of them. It could be any three or one, but I like using two. The magician turns around so that the volunteer can show the cards to the rest of the audience, and then turns back and names the two chosen cards, by number, not by suit. You can repeat this with the next 10 cards, and the next 10, and the last 10. Here's an alternative using the full deck. After the riffle shuffle, deal 2 cards to the volunteer and 2 to yourself, in any order you like. Look at your cards briefly, then tell the volunteer the suits of their 2 cards. This can be repeated for another 4 cards, and so on. When you first reveal the secret, the full import of this amazing trick may not be obvious to all until you remind them that the cards had been shuffled. For the first trick, start the deck stacked ace through 10, repeated in the same order. The suits are irrelevant. After the shuffling, the cards may be a little bit out of order, but every set of 10 cards starting at the top will still have ace through 10. Amazing. With your back turned, take a peek at the cards you still hold. Whichever cards from ace through 10 that are missing are being held by the volunteer. For the second trick, stack the deck rotating the suits. For example, spades, diamonds, clubs, hearts, spades, diamonds, clubs, hearts, and so on. After the shuffle, every set of 4 cards starting at the top will still have one of each suit. Whatever is not in your hand is in the volunteer's hand. That sounds really simple, but wait, the deck was shuffled. That's the amazing, magical, mathematical fact. Essentially, any repeating pattern you build into the deck will be maintained through the process described. Cut the deck, deal 1 at a time, riffle shuffle. And that's called a Gilbreth shuffle. We'll take a quick look at why this is true, along with its surprising connection to the Mandelbrot set. Let's see what happens with a small example of a 10-card deck. Let's call the cards 1 through 10 from top to bottom so the deck looks like this. And let's say that the 4 cards are dealt into a new stack, like so. Notice that the new stack is in reverse order. A riffle shuffle might produce something like this, where the cards alternate left and right for 2 pairs, then 2 cards from the left come down before the next right-hand card. Let's look at some properties of the new deck. Well, the top 4 cards come from 3 through 6. The top 5 cards from 3 through 7, the top 6 from 3 through 8, and the top 7 from 2 through 8. The first N cards are all consecutive. Some order is preserved, and the cyclical nature of the original deck takes care of the rest. If the original cards were stacked by suit, then 1 through 4 get duplicated by 5 through 8, and so on if the deck is larger. A nice way to match up similar suits is to take the numbers mod 4. A number mod 4 is defined as the remainder after dividing it by 4. So 5 mod 4 is 1, and this indicates that 5 and 1 were the same suit. 6 mod 4 is 2, so 6 and 2 are the same suit. Let's look at the deck mod 4. 1, 0, 2, 3, 3, 0, 2, 1. The first cards are all different suits, and the next 4 cards are also all different suits. Each set of 4 starting from the top is distinct mod 4. Well, let's try mod 5. 0, 4, 1, 3. Each set of 5 starting at the top is distinct mod 5. This will work for any mod, i.e. any length of pattern like suits built into the deck. It's been proven that the consecutive and distinct properties illustrated above will always hold. Let's think back to our tricks. The ace through 10 trick uses 40 cards and mod 10. The rotating suits trick uses 52 cards and mod 4. Notice that in this trick the colors also alternate, like 52 cards and mod 2. It is nice if the length of your pattern divides evenly into the size of the deck used, though that's not necessary. So the ace through 10 trick could be a full deck trick, for example using 52 cards and mod 13. And the trick will work with Uno cards or any deck that has patterns. As teased above, there's a connection to the Mandelbrot set. You might want to watch the 2 episodes on this amazing set. For now, we just need the concept of iterates and cycles. The function x squared minus 1.9407, and actually the 1.9407 is approximate. That has a 4 cycle because starting at x equals 0, the iterates are plug 0 in, you get negative 1.9407. Plug that into the function, you get 1.8259. Plug that into the function, you get 1.3931. And 1.3931 leads back to 0, starting the cycle all over again. The 5th iterate equals the 1st iterate. The 6th iterate equals the 2nd iterate, and so on. This probably sounds familiar. And impressive encoding is used to make the connection precise. So the first row here lists the numbers in order of the iterates. We went from 0 to negative 9.407 and so on. The second row ranks the numbers by size. 0 is the second smallest, negative 9.407 is the first smallest, and so on. Start on the second row where the 1 is, and go to the left, writing down the numbers as you go. So you go to 2, wrap around to 3, 4, and 1. And 2, 3, 4, 1 is a Gilbreth shuffle. Here are the details. The deck starts at 1, 2, 3, 4. Dealing 2 cards makes 2 piles, 3, 4, and 2, 1. Then riffle shuffle in the order right, left, left, right. You have 2, 3, 4, 1. There's a perfect one-to-one correspondence between Gilbreth shuffles and the Mandelbrot sequences. Amazing. This is one of the wildest examples of a wonderful property of mathematics. Often by abstracting out a set of operations, you uncover connections that you would have never believed.